Hello, I've been asked to go over question 6 from the work exercises on the which I did in the last video, but it came out with a really bad sound, so it wasn't very easy to understand. So I'm going to go over the question again. And this was the question. There was a skier holding on to a drag lift, which was this kind of rope here, pulling in that direction at 15 degrees to the parallel to the slope. The slope is 20 degrees to the horizontal, and they give you a bunch of forces. They tell you that the force of the drag lift wire, which is this wire here, is 320 newtons. So that's 320 newtons. The perpendicular contact push of the snow is 620. So that one is 620 newtons. The frictional force of the snow is going to be in the opposite direction to his movement, and they tell you it's 55 newtons, and his weight is 750, which will be vertically down 750 newtons. So as always with these questions, we split the force up, the gravity one. We need to split it in the two directions that are going to be useful, and the two directions are perpendicular to the slope and parallel to the slope, as always. So let's see, perpendicular to the slope would be the continuation of the line of the normal, and that would be this line. And if we wanted to get the weight along that line, we need to know this angle here, and I've proved that already in other videos, the ones on things of slopes, that this angle 20 is the same as that angle there, 20. They're both the same angle, so if that's 20, then this here is a hypotenuse. So if we link it up properly, the triangle looks something like that, where this is a right angle, and this is the hypotenuse, which is the longer side, 750. So therefore this here would be 750 cos 20 into the slope, and the 750 down the slope, which is the one that's gonna sort of go along the same direction as the friction, is this one here. It's going to be 750 sine of 20, because it's the opposite, sine of 20. Again, if you ever forget, slope, sine. So parallel to the slope is normally the sine for slope. Okay, and cos for perpendicular. Doesn't really have a trick to remember it, but if you remember this one, then you know that the other one is the cos. Okay, so having seen all of that, then we can answer the questions in the sheet. It says, calculate the work done by each force on the skier as she is dragged 30 meters up the slope. So she's going to travel displacement of 30 meters, and we want to know the work done by each force. So what are the forces? We have F1, we're going to call it the drag lift. F2 will be the doesn't matter really, the normal force, normal contact force here, the 620 from the snow. F3 will be the friction, and F4 will be the gravitational component, the weight down the slope, the weight down the slope. And then there's also this force to take into account, but I'll explain later why that doesn't matter so much. Okay, so there is a a big mess there with lots of arrows and stuff, so I'm going to try to draw this a little bit more simple down here, a little bit simpler. So what we have really is the skier here, center of mass of the skier, then there's a force in that direction which is at 15 degrees to the direction of motion. Then there is one that is along the direction of motion of 55 newtons. Then there is this one perpendicular to the direction of motion, which is 620 newtons. Then there's also along this direction the component of the weight, which is 750 sine 20. 750 sine 20. And then into the slope there is the 750 cos 20. Okay, and I think that's all of them. Let me see. So and this one has a size of 320 newtons. Yeah, that's it. Okay, so these forces. Now, force number one is the drag lift, so it's this one here. So if we wanted to know how much work that force is doing, it's doing the value of the force times the distance that it travels, but the value of the force is not going to be the whole 320. It's going to be however much of that is going along this direction parallel to the slope. So if we want to know that, we need to do the cos, because it's the adjacent, right? This is the real force, so that's the hypotenuse. So then the joining line would look like this. That would be the right angle, this would be the adjacent, and so this would be 320 cos 15. So that's how much of that force is going along the direction of motion, and therefore if we multiply that by 30, we should get our work done in that direction. I'll let you do that and see what you get there. Similarly with this one is, well, actually force number 2 is the normal contact force, so this one here. So what do we know about forces and work done? The direction of that force is completely perpendicular to the direction going up the slope. Right, that's the definition of a normal force. Is normal means right angle, so this angle here is a right angle. So that force is not going to help you at all go up or down. It's not going to slow you down. It's only helping you not to go through the floor. So that's because it's at right angles. That's at right angles to the direction of motion. There's no work done from here. So normal contact force does no work at all. That force does no work. Similarly with the perpendicular component of the weight, the one going down into the slope, neither does that one. This one doesn't do work either. Okay, so that's why I've only included here the weight down the slope. The weight perpendicular to the slope, similar to this one. No, okay, weight perpendicular, no work. This one, no work. This one we already know how to calculate it. It's just the cos of that force and that angle, 320 cos 15 and 30. Friction force is pointing along the same line as the movement, so that's fine. That's gonna definitely do work, and the full 55 are going to be involved, but the direction of the force is the opposite to the direction of the movement. So then we need to do the 55 times the 30 meters that it moves, but we need to put a big minus in front, because the direction of this guy and the direction of the motion are different, so the work's going to be negative. In other words, it's going to be taking away energy from his body, which makes sense. Well, from his movement. If he stopped being pulled, he will very quickly stop, and that would be the main cause, together with gravity, to make him stop. So the one missing, so this one we know how to do already, and the one missing is gravity down the slope. So therefore we have 750 for the weight times sine of 15 times 30 meters that it moves. Okay, and this force here, sine 15, is along the same line, because we've made sure that we've done that with this here. But it's also in the same direction as the friction, so it's going to be negative because it's in the opposite direction to the motion. So there you can get the work done through all of the forces. And to show that the total work done on the skier is 0, you just have to add them all and subtract the ones that are negative, but really you're adding them all, and the ones that are negative are going to subtract themselves automatically. And you should get something, and if you write it in kilojoules, you should get something like 0.0 some numbers. So that's roughly 0 overall total work done on the skier. Okay, the answers are slightly different to the ones on the sheet, the ones that I got. I think they're off by a little bit, and well, hopefully you can do that fine. I'll see you in the next video.